Now in this video I'm just gonna show you integration through substitution. Now say I have something like this to the power 3 dx. Now when do we apply substitution on integration? Now notice that you have a function inside another function, because basically we can say we have some function to the third, but on top of that we have another function inside that function. So it's basically a composition. So when you apply substitution, you can only do that if you have a composition, because like here we don't have if you go back to my videos of introduction to integration, there's no relation to this. So we must force this in order to give us that formula where we know which we can then integrate this to be u to the third plus 1 and 3 plus 1. That's the formula I gave, but now here we have a composition of that. So that's when you're going to apply your substitution. So how does that work? So you're going to say let u be the inside function, let u equals x minus 4. But then if you derive u, you're going to have 1 du. Then if you derive x, you're going to have 1 dx, or just dx. Then the derivative of 4 is 0. That means that du is equals to dx in this case. So if du is equals to dx, then we're going to have this. Remember, x minus 4, in this case it's u. So we're going to have the integral of u. Now we have to the power 3. And then now dx is equals to du. Then you're going to have this. Then from then you can apply that formula I showed you when I was introducing integrals. And then you're going to have, this will be u to the power 3 plus 1, which is 4, divided by 4. And then you add a constant to that. But then you have to substitute that u back. U is the same as x minus 4. Then you're going to have something like this. So that's substitution. You can only do substitution if you have a composition of functions. Notice how I analyzed what to substitute in them. Now let's say I have the integral of the square root of 2x plus 4. If I have the integral of 2x plus 4 dx, how do I analyze my u? Now notice that here you can have a function like this, 2x plus 4. You have a linear function that is inside a square root, or a radical function in that case. So you're going to have the square root of function. You're going to have this, and you have another function where y is the same as 2x plus 4. So you can say this is x, but I'm basically showing you the relation of this, where u is equals to 2x plus 4. So that's what you're going to do here. It's just a composition. So let u equals 2x plus 4. Now du in this case is going to be, the derivative of 2x is going to be 2. So I have 2 dx. The derivative of 4 is 0. So you have du equals 2 dx. That means that dx is equals to du over 2. So then you can work out that integral there. Then that integral will be the integral of the square root of u, where dx is the same as du over 2. So this integral can further be, you can take the half outside. Then you're going to have half outside. And then you have the integral of the square root of u, which is the same as u to the half du. Then you apply that formula I showed you when I was introducing integrals. Then you'll have a half. Now you're going to have u to the power half plus 1, which is 3 over 2, divided by 3 over 2. Then you add your constant. Then you're going to have something like this. Then you're going to further simplify this, so it's going to be u to the power 3 over 2, since you're going to say 1 times this one. And then 2 times 3 over 2 is going to be 3. And then you add a constant. And then you're going to basically have something like You substitute that u back, and now remember u is the same as 2x plus 4. Then you're going to substitute that back there. So you're going to have 2x plus 4 to the power 3 over 2. Then you divide by 3. Then you add that constant there. So this is basically what you're going to do if you have a composition of functions. Notice that you must analyze the outside function. In this case, you're going to have u to the third. Then the inside, it's x minus 4. So that's basically what you're going to do. So the whole idea in this is to manipulate this equation to give you what you know. Remember, we can integrate this. You must manipulate that equation to give you the integral that you basically know. So that's just the basic idea in integration using substitution. Now, what about this one? You basically have 2x multiplied by e to the power x squared. How do we analyze u in this case? Well, notice something. This is the derivative of this. So it basically tells you that you can let u equals x squared, since the derivative, you can relate this with this. You can relate x squared with 2x. This is the derivative of this top function. If you derivate x squared, you're going to get this. And you have e, so that means you can just say let u equals x squared. Wait, let me just show you something. Basically, it's like, remember when we were deriving e to the power f of x? When we were deriving this, the derivative of that will be the derivative of f, which is this, multiplied by the whole function here. So basically you can already tell that the answer to this is e to the power x squared. But you want to show the steps that the answer is going to be e to the power x squared plus a constant. So let u equals x squared. Then du is the same as 2x dx. Now that means that dx is du over 2x. Now, do we need to solve for x here? So basically, it's like we can neglect that, since we have this 2x. It's gonna cancel with this one, so you don't need to solve for x. When you integrate, you must basically have one variable. But then we don't need to worry about 2x because it's gonna cancel with this one. Then we have the integral of 2x. You have the integral of 2x multiplied by e to the power u, where dx is now du over 2x. The 2 can cancel, and then you have the integral of e to the u du. Now, remember that if you derive e to the u, you're going to have e to the u. It doesn't change. So you're going to have e to the u plus a constant. Why? Because we are looking for what derivative will give you e to the u. If you derive e to the u, you'll get e to the u. That's if you take du of e to the u, you'll still get e to the u. So you still have to add the constant there. Now, what's u? U is equals to x squared. We just basically discussed that. So it's going to be e to the x squared plus a constant. So that's basically how you can evaluate integrals using substitution. Where do you do substitution? If you have composition of functions. Let me do the last one here. Suppose you have the integral of 2x minus 6 multiplied by the square root of x minus 3 dx. Now, how do you find the integral of this? Now, notice that here you can take a factor, which is 2. And so if you factor by 2, you're going to have the integral. You take the 2 outside, then you're going to have x minus 3 multiplied by the square root of x minus 3, and then you have dx there. Notice that you have this composition right there. So you have a linear function that's inside a square root. So you're going to have u equals x minus 3 then that means that du is equals to dx. Since the derivative of x is 1, then you must show that you are deriving with respect to x. The derivative of a constant is 0, then du is the same as dx. Then you're going to have 2, the integral of u multiplied by the square root of u. Then you have du, since du is the same as dx. Then you can further proceed here. You have 2, and then this is the same as u to the power 1. It's the same as to the power 1 multiplied by the square root, just tells you that it's to the power half. And then you have this case there. Then you can further proceed with this one, and then you're gonna have 2, the integral of u to the power 3 over 2 du, and then you can use that rule that I showed you. Then you're going to have 2, the integral of this. You just add 1 here, and then you divide by that. 3 over 2 plus 1, that's 5 over 2. Then you divide by, multiply by u to the power 5 over 2, divide by 5 over 2. Then you add your constant there. Then this will further simplify. If you multiply both the numerator and the denominator by 2 over 5, if you multiply the numerator and the denominator by 2 over 5, you're going to have 4 over 5. Since that 2 over 5 is going to multiply with 2, so you're going to have 4 over 5 multiplied by u to the power 5 over 2. But then you still have to add that constant. Then what's u? U is equals to x minus 3. So you're going to have 4 over 5 multiplied by x minus 3 to the power 5 over 2, then you add a constant. So that's basically how you can integrate this using substitution. You only do that if you have a composition of function, and you can relate that, like in this case, you have the product of two functions, but there's a relation with this one, so you can just use substitution on that one. But what about the cases that don't work on substitution? And that's where you have to integrate by parts. So in the next video, I'm just gonna introduce integration by parts and how you deal with that, and when do you apply integration by parts. And in this video, I just showed you where do you do substitution. You do substitution if you have a composition of functions. Like in this case, I just showed you the relations, and also in this case, also here, I showed you that you have 2x plus 4 that's inside a sad, and we can let u be to whatever that's inside the square root. But some cases, this substitution doesn't work. So there's more than one type of substitution. There's also trigonometric substitution. You only apply that if you can relate that to right angle triangles and that kind of stuff, such as the square root of 1 minus x squared. And that's where you have, if you were integrating this, you must use trigonometric substitution. That's because you can relate this to a triangle like this, where you have your hypotenuse to be 1 and the other side to be x, and the other side will be the square root of 1 minus x squared. So you can basically tell that this is from a right triangle, then you can use trigonometric substitution. But then for now, I was just doing u substitution. We cannot relate this to triangles, so we just use a variable instead of trigonometric substitution. So this is basically it about integration using u substitution. You analyze what's your u. You just have to first find the composition of that, and you can be able to solve that. Thanks for watching. Don't forget to share and subscribe.